Hello, everyone, and welcome to our webinar, GPT-4o for developers, hands-on with OpenAI's spring release. My name is Matt Brown, and I will be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars, 2 to 3 per week, demonstrating AI and data use cases and new tools and technologies. I post about these upcoming webinars every week, so if these topics are interesting to you, please feel free to connect with me on LinkedIn to stay in the loop. I'd also love to hear your feedback or ideas, suggestions on new topics that you'd like to see in future sessions. Speaking of future sessions, we've got some awesome new webinars on the upcoming calendar. As you can see from this screen, we've got how to build local LLM apps with Ollama on May 20th. On May 22nd, we've got LLMs in fraud detection. And then on the 29th, we have supercharge your MySQL apps 100x at scale with no code changes. So if any of those sound interesting to you, feel free to register. I'm going to put those links into the chat in a minute, or you can take a photo or screenshot of those QR codes. It'll take you to the same place. Also, we have our new functionality live, auto RSVP to future AI webinars option. So if you visit any of those landing pages, there is now a checkbox to auto-register, which will add these future upcoming Zooms automatically to your calendar. Obviously, you don't need to attend every webinar live if you don't want to, but this is a great option for those who have requested this functionality so that they can automatically receive the video recordings and the Zooms and the GitHub links via email for all of these useful sessions without having to click every single one. So anyways, try that out if you like. Ayush Pai is a computer science student at Georgia Tech. We originally found him online after he created a viral AI basketball referee demo that's really cool. I suggest check it out. It's on YouTube. Since then, we've partnered with him on lots of projects demonstrating the power of SingleStore for AI use cases. Welcome, Ayush. Glad to have you again. The floor is yours.
Awesome, thank you. And I'm going to give the floor to Akmal real quickly for a brief introduction into SingleStore.
Oh, great. All right. Thank you very much, Ayush. Thank you, Matt. And thank you all very much for joining today. I see a lot of interest for today's topic. So I know Ayush's demos are always awesome. So stand by for that. I'll just do my for 2 slides on SingleStore. Okay, so as a company, this slide is useful, particularly from a business perspective, because it shows you that we have actually been around as a company formerly known as MemSQL way back in 2011. And then you can see some milestones there along the way. If you're sharp-eyed and you look roughly in the middle there, 2017, you see vectors plus semantic search support. So the product has actually had vector capability for quite some time. Originally, I think it was a financial customer that requested this capability, and it's been improved upon significantly earlier this year with a dedicated vector type, ANN indexing, and so on. Look, far too much information to cover today. So roughly there, you can see that in terms of revenue, we are now a $100 million plus annual recurring revenue, ARR company. So that started to grow significantly between 2017 and 2018 there, and over 350 global customers. And that started to grow roughly there, as you can see, between 2019, 2020. I think just in the last webinar, someone asked me the question, is it 350K? Customers? Well, we'll hope to get to that someday, but not at the moment, okay? But you can see the investors along the bottom there, well-known brands, well-known names, and in terms of our customers as well. I mean, these are Fortune 500 companies, so many of them are documented on our website, and we cover the whole range of verticals as well. Thanks, Ayush. Next slide, please. So architecturally, so this is good if you happen to be a developer, because kind of this gives you a little bit of an indication in terms of the capabilities of the technology. So at its heart is this kind of universal storage, okay? So this ability to store both OLTP and OLAP data and be able to process that as well. Fairly unique in the industry. Some other vendors have announced capabilities. We're still waiting for delivery of those from them, but SingleStore has had this for a little while now. And on the left-hand side, you can see the fast ingest in CDC. So the last couple of months, if you've attended any of my webinars, for example, you know that I've covered Kafka integration, and we've talked about Spark, and then we can work with other technologies as well, HDFS, Hadoop, for example. And the animation there on the left-hand side shows the pipelines, the sort of ingest in parallel from these various data sources. Along the bottom there, you can see we work with the 3 major cloud providers in the Western world, AWS, Google Cloud, and Microsoft Azure. You can actually run the technology on-prem as well. There's a Docker container too. But seriously, the link that Matt is going to share, and I think it's probably in the chat by now maybe, or if not, he will post that there shortly. If you click on that and you sign up, get access to the portal, just accessing SingleStore in the cloud is probably the easiest way to get started, simply because there's nothing to install locally. Quickly then on the right-hand side, you can see the stored data type. So relational at its heart, I mean, that's where the technology has really come from, but we do lots of other things as well. Geospatial, Lucene, full text search engine, key value, JSON support has been there for some time. Even better now with SingleStore, this Kai, which allows MongoDB compatibility. Time series data as well, we covered that not so long ago, and vectors, which we mentioned a few moments ago. One quick point there. So sometimes we get asked the question, you know, how is SingleStore different from, say, Pinecone or ChromaDB or Weaviate? This diagram hopefully will give you an idea. So we are not just a vector database, although you can use it purely for vectors if you wish, but we do lots of other things as well. And typically in an enterprise environment, you have a range of capabilities that you need. And if you simply kind of glue together a variety of different products, you end up, you know, with some issues in terms of integration. So from a developer's perspective, this architecture is great because you have a product that you can learn. From a business perspective, it's great because it improves your return on investment, lowers your total cost of ownership, and therefore it's great from sort of both perspectives. And with that, I'll step down now and hand over to Ayush, and Matt and I will be there with the answering the Q&A, and so we'll do our best to hand over now to Ayush. Thank you, sir.
Great. Thank you for that great introduction, Matt and Akmal. And let's actually just hop straight into our demo today. So today I'll be presenting on OpenAI's newest model, GPT-4o. Before we get into that, let's get into a brief introduction of what GPT is. So GPT stands for Generative Pre-trained Transformer, which is a type of neural network model that's designed for natural language processing tasks, and is developed by OpenAI. GPT models really excel at understanding context, generating human-like text, translating languages, summarizing text, and much more abilities. And even more so now with their multimodal abilities with text, audio, and video, and all these different types of modalities are coming into this one model that we're seeing with GPT-4o. These capabilities are really achieved through extensive pre-training on a vast corpus of text data, and these models are called these foundation models. GPT-4o really represents the latest advancements in the series. It's a multimodal model that can process text, audio, and visual inputs with just a single neural network, making it a really powerful tool for diverse applications. And the model leverages the transformer architecture, known for its efficiency and handling large data sets and ability to process input data in parallel. This really enables GPT-4 to achieve high performance, GPT-4o to really achieve high performance in various complex tasks. And in this webinar, we'll kind of explore the technical aspects of GPT-4, including its architecture, training process, and potential applications. And we'll have a live demo of me using this as a real-time assistant for solving math problems and coding, kind of replicating some of the demos that you saw in the OpenAI demo, but building on your own, right? So kind of the journey to GPT-4o is built on decades of research and development in neural networks. Let's take a brief look at some of these key milestones. So in 1950s, we had the neural network introduced, concept of artificial neurons laying the foundation for neural network research in the near future. The work was really set the stage for more complex neural architectures. As we saw kind of in the 1980s, we had these recurrent neural networks, which were introduced to handle really sequential data, right? Enabling models to process sequences and information, such as text, time series data. However, RNNs really struggled with these long-term dependencies due to something called vanishing gradients. To really address these issues, in 1997, there's this new paper came out that was called Long Short-Term Memory, LSTM architecture, and these really introduced these memory cells that could maintain information over long periods of time, really effectively capturing long-term dependencies and improving upon the performance on sequence-based tasks. And kind of like the biggest breakthrough in the last, 10, 15 years in AI is in 2017, the introduction of the transformer architecture through this paper called Attentional is All You Need really marked a significant breakthrough. And transformers really eliminated the need for, recurrence and sequence modeling and allowed for parallel processing of input data, which really significantly improved the processing and training efficiency and scalability. And this innovation really paved the way for these models like GPT, enabling them to really handle large data sets and capture complex patterns within text. In 2018, Google introduced BERT, which was revolutionized NLP by using bidirectional training in their transformer architecture for context understanding and further advancing the capabilities of these language models. And these advancements culminated in the development of GPT-4o, which is now our state-of-the-art multimodal model that can process text, audio, and visual inputs with a single neural network. So let's go into these architectures really quickly. So the neural networks at the core of modern AI technologies, they consist of interconnected layers of these nodes called neurons, right? Each layer transforms the input data using weights and biases to produce a final output. And a typical neural network architecture has an input layer with one or more hidden layers and an output layer. So the process begins at the input layer. So we have data that's fed into the network. Then the data is then transformed into using these hidden layers and uses these activation functions, which introduce nonlinearity into the model, really enables them to learn, complex patterns, stuff like that. So each neuron in the hidden layers is connected to every neuron in the previous layer and connected to every neuron in the next layer, forming this next really, really dense network of connections. And training these neural networks really involves, using large data sets, optimization algorithms, and gradient descent. Gradient descent, basically what it does is adjust these weights and biases to kind of minimize the error between the predicted and actual outcomes of your data set. And this process allows the network to, learn the data and improve its predictions over time. And it's kind of the base of all these GPT models, how the training works for those. This brief introduction kind of sets the stage. Let's move on to some more of these other architectures. So RNNs are specifically designed to process sequential data that I kind of talked about earlier, maintaining information across time steps to handle tasks like language processing, time series data. Unlike traditional neural networks, RNNs have these loops, as you can see in this diagram, that allow them to retain information from previous inputs, create a form of memory that actually captures the context of the previous inputs. Really important in especially language models that we're talking about today. You really want to have what came before, or can have a prompt that actually gives it context to give what the next generation is of words. And if you think about how these GPT models works, it's basically predicting what the next word in the sequence will be. And it's taking everything that's kind of generated before and taking that all into account to create the probability distribution of what the next word will be. So, how we know RNNs obviously struggle with this long-term dependency. Obviously occur because of this problem I kind of talked about earlier called vanishing gradients, which means during backpropagation, which is the process where these neural networks are training, what happens is the gradients become way too big or way too small, which kind of really destroys the training process. And so to solve this problem, the long short-term memory was kind of created, right? So this essentially overcomes the limitations of RNNs by introducing memory cells that can maintain information for long periods of time. They really effectively capture long-term dependencies. And the architecture of all LSTM includes these gates called input, forget, and output gates. And these kind of controls the flow of information throughout the network. These gates allow for the network to decide, which information to keep at every step, which information to forget at every step, and which information to output to the next layer. At every single time step, it does these things and enables the model to retain relevant information over longer sequences and improve performance on tasks requiring long-term memory, such as large language models and language modeling, time series prediction. And allows it to make these predictions in the short term and long term and remove the information that's irrelevant for the long-term dependencies. So transformers kind of utilize the self-attention mechanism. It's called self-attention, and it kind of allows it to weigh the importance of different words in a sequence, right? It allows them to capture relationships in context over long distances without really relying on sequential processing. So unlike RNNs and LSTMs, these transformer models really process input data in parallel. And it significantly improves the training efficiency and scalability for larger data sets. And larger data sets is kind of how these large language models work. Like you kind of saw with GPT-3, you had 175 billion parameters. And now with GPT-4, you have like in the trillions, right? It's just continually increasing. And you really need that efficiency for scaling with these larger data sets. The transformer architecture really employs an encoder-decoder structure, where the encoder processes the input sequence to create a rich representation, and the decoder generates the output sequence based on this representation that was generated. So this design has kind of revolutionized the natural language processing scene, allowing us to see the development of these really highly effective language models such as GPT. And now that we've covered kind of the models and architectures behind them, let's dive deep into the large language models here and with the GPT series of models. So LLMs are kind of trained on a vast amounts of text data and from a diverse amount of sources, really enabling them to learn patterns and contexts and relationships within language. So these models leverage transformer architecture that we kind of talked about in the last slide. And they really allow them to process and generate text really efficiently. So the training process for LLMs kind of begins with this pre-training phase on a large corpus of data, trained on the entire internet, something like that, where they use self-supervised learning. This essentially helps the model to learn general language representations. And after the pre-training process, the LLMs are kind of fine-tuned on specific tasks for specific domains. If you're making a chatbot, you want it to do X, Y, and Z. If you're doing something else, customer support, you're going to want to fine-tune it on specific data sets to accommodate for a smaller domain. And finally, by combining this broad knowledge of got from this pre-training data set with the specialized skills acquired during the fine-tuning process, LLMs can really adapt it to like a wide range of tasks, allowing them to be really versatile and efficient in natural language processing applications. So right before the GPT models came out in 2018, Google introduced something called BERT, which stands for bidirectional encoder representations, and essentially from transformers. And essentially, what BERT does is uses bidirectional training on the transformer models that we talked about to really understand the context from both directions, which is a significant departure from unidirectional training of previous models. And this really allowed it to consider both preceding and following words in a sentence, allowing it to provide a lot deeper understanding of the context when generating these responses. So BERT really excelled in various natural language processing tasks such as question answering, sentiment analysis, entity recognition. There's a lot of different really cool applications that we saw with BERT by pre-training on a large text of data and then fine-tuning for specific downstream tasks. BERT really significantly enhanced the performance across these applications. And the architecture of BERT involves, you can see on the right of the screen, the stacking of the multiple transformers, and each layer processes the input tokens to generate a contextual embeddings. And these embeddings are used to perform various NLP tasks, and the bidirectional nature and fine-tuning capability of BERT made it really a really cool foundational model, one of the first foundational models that we saw in this NLP space. So it really influenced a lot of the next developments in the field, including the developments that led up to GPT-4o. So speaking on that matter, let's kind of talk about the GPT model series of models that we kind of see over the last 4 or 5 years here. So GPT-1 was introduced in 2018 and introduced unsupervised pre-training, following a supervised fine-tuning, allowed it to demonstrate the potential of these really large language models. It laid the foundation for leveraging like large-scale data to understand and generate text. In 2019, we got GPT-2, kind of showcased really advanced improvements in language understanding over GPT-1, and its generation had 1.5 billion parameters, and it was really capable of generating coherent and contextually relevant text, marking a substantial leap in AI capabilities. In 2020, we saw GPT-3 released, and this expanded the parameters to 175 billion. And it kind of set new benchmarks in NLP tasks. It became the state-of-the-art model, and it really demonstrated, advanced text generation, comprehension, and even code generation, which now we know is a really, really valuable tool from these large language models. it really became a versatile tool across various domains. GPT 3.5 was released in 2022, and it really enhanced the model, integrated into ChatGPT, obviously, and that was released to the public, improving, conversational AI abilities and, provided more context-aware and engaging interactions. And it was really fine-tuned to do that. GPT-4 that we saw released last year in 2023, towards the end of the year, really leveraged, the main thing about this model was it leveraged these multimodal inputs. For the first time, GPT models were integrating with vision, and it was fine-tuned for specific applications to enhance the performance better. And yeah, so in 2024, we see this GPT-4o model, and this is the O here stands for Omni. And what that means is it can reason across audio, visual, vision, and text in real time. So essentially, kind of how it was described was it's one neural network for all three tasks. It's one neural network that was trained on all three modalities. And this latest iteration kind of represents the pinnacle in multimodal AI, really capable of understanding and interacting in a more human-like manner than ever before. So GPT-4 is OpenAI's newest flagship model that can reason across audio, vision, and text. Obviously, the O stands for Omni, and its ability to, it's a remarkable ability to really integrate across multiple modalities really seamlessly. So one of the standout features of GPT-4 as well is its ability to respond to audio inputs in as little as 232 milliseconds. With an average response time of 320 milliseconds. And the speed is really, really comparable to human response time in a conversation, really making it interactions kind of feel a lot more intuitive and fluid and not having to wait for these responses. Additionally, GPT-4o is designed to be twice as fast as GPT-4 Turbo, the previous model, and also 50% more cheap in terms of cost per token than GPT-4, making it a really efficient and also cost-effective solution for a wider range of applications. These enhancements not only improve the performance, but also broaden this accessibility of these AI capabilities. It's a multimodal model that can reason across all these different modalities, and that's kind of the difference between GPT-4 and GPT-4o. GPT-4o is only between images and text, and it was pretty slow at doing so. And GPT-4 is this all-in-one multimodal model that can do basically all three. Another thing that's really important about this new model that was went under the radar with other multimodal capabilities is the lower latency. And this is really critical for building real-time enterprise applications where swift and efficient processing of information is really essential. So GPT-4o, with its significantly reduced latency compared to GPT-4, is particularly well suited for such environments. And as we can see, as shown in the comparison, GPT-4 has a latency of 0.37 seconds compared to GPT-4's 0.55 seconds. And this is really, really important. And this makes it, faster response times, which is really crucial for, applications like customer support, financial services, patient, whatever like domain, it doesn't really matter. Faster responses is always going to be better. And in terms of like their benchmarks for this model, so LMSYS, I'm not sure exactly what that stands for, but this company, they have this chatbot arena, and it's basically a platform where users can prompt two anonymous language models, right, and vote on the best response and reveal the identities of these models. And essentially, it's completely anonymous, so they don't know which model they're voting for. And essentially, GPT-4o scored an impressive 1310 ELO, ranking, which is a significant jump in the top 5 performing models. And this highly ELO kind of really shows the superior performance in generating, really coherent, contextually accurate, and engaging responses compared to some of the competitor models. So there's a company called VLM AI who also had an initial benchmark released a couple of days ago, kind of, on on 3 different categories here. So for data extraction, GPT-4, and it's kind of comparing GPT-4o and GPT-4 Turbo. GPT-4o for data extraction really demonstrates better quality and lower latency, but struggles with identifying 60 to 80% of data correctly, indicating room for improvement in this area. But GPT-4 also kind of lacks in this data extraction tasks. Classification, GPT-4 achieves the highest precision at 88%. GPT-4o, and makes it really best for avoiding false positives. For verbal reasoning, GPT-4o shows improvement in tasks such as calendar calculations, time and angle calculations, and also antonym identification. Though this faces challenges with it does face challenges with word manipulation, pattern recognition, analogy reasoning, etc. So these are kind of some benchmarks just comparing, but overall it looks like it seems like a lot faster and overall better performance in terms of accuracy. So this is I just wanted to show this video. If you missed, this is just a quick 1-minute clip from OpenAI's spring update. GPT-4o has a really great ability to produce significant voice variations, which is an upgrade from the typical monotone voice found in the current models. This feature enhances the natural language and allows the models to create these a lot more human-like situations when they're talking to users. So I'm not sure. Let me make sure I'm sharing audio. Let me just. Okay.
Pretty good.
What's up?
So my friend Barrett here, he's been having trouble sleeping lately. And I want you to tell him a bedtime story about robots and love.
Oh, a bedtime story about robots and love? I got you covered. Gather round, Barrett. Once upon a time, in a world not too different from ours, there was a robot named Byte. Byte was a curious robot, always exploring.
Started this story, but I want a little bit more emotion in your voice, a little bit more drama.
Got it. Let's add some drama. Once upon a time, in a world not too different from ours, there was a robot named Byte.
No, ChatGPT. I really want maximal emotion, like maximal expressiveness, much more than you were doing before.
Understood. Let's amplify the drama. Once upon a time, in a world not too different from ours, there was a robot named Byte. Byte
Actually, can
was
you do this in a robotic voice now?
initiating dramatic robotic voice. Once upon a time, in a world not too different from ours, there was a robot named Byte. Byte was a curious robot, always exploring new circuits.
Seeing, Barrett here, calm down a little bit. Can you end the story, but do it in a singing voice?
And so Byte found another robot friend, and they lived circuitly ever after.
Awesome. So that's some cool
Pretty good.
What's up?
From OpenAI, and kind of like demonstrating their really cool voice that they've integrated directly into the GPT-4o model. Kind of demonstrating the vision abilities as well. This is like a quick example I did. Its ability to reason with images. In this example, it's an image of a subway sign provided to the model along with a query about train times and destinations. And I'm using the API here to generate giving it information about for example, like what time will the R train arrive and where is it going? And it's able to take the image and do the OCR and then reason based on that. So GPT-4o, kind of demonstrates really impressive handwriting OCR with its accurately interpreting and verifying, handwritten homework in this example. And this is kind of something I'll show in the demo in a couple minutes here. But for the first problem, obviously, it's kind of showing, they're doing the correct step, kind of explaining the whole process of them going through this. And this is really cool because we have this image capabilities, but then we're also combining it with voice abilities. So you can imagine the possibilities of like an AI tutor or something like it, where it's like you have an assistant that's helping you do your homework or understand concepts in school, stuff like that. And then here's another example. You're taking this really complex formula and then converting it into this latex format, which is really, really popular for a lot of research and writing a research paper in general. Awesome. So let's get into our code and demo for today. So for today's demo, we're going to be building some of the applications that we kind of saw in the GPT-4o release during the spring release from OpenAI. So essentially what they had in those demos where one of the demos where you could talk to it about your code in real time and you would share your screen and it would basically like understand your code and you can talk back to it forth out loud. And the other demo that I'm going to demonstrate here is the ability to, when you're doing like a math problem on like a piece of paper, you can show them with your camera like what you're doing and then it'll like give you feedback on, are you going in the right direction, stuff like that. And currently, so GPT-4o model is released from, using the OpenAI model, but you can't directly access the multimodal abilities with the voice yet. So I'll show you how you can do that in kind of like a hacked way where I directly integrated some voice modules from Python, and then it's not going to be as real time as you saw in the demos, but obviously it's the best we can get until OpenAI releases their full-fledged model to us. So let's get into that. Let me share my screen for the code really quickly. A moment, please. Awesome. Let me just move this really quickly. Okay, cool. Yeah, so let's get into, so I have these two programs here, and you should have access to the GitHub. It should be sent to the chat, and you guys can all try it out as well. But I have these two programs. One of them is an assistant that you could use with your camera for solving like math equations and stuff like that. And the other one is a computer assistant that uses your screen to help you with coding problems or whatever you're doing on your screen. Additionally, uses RAG to give you additional context on if you're using an API and you're trying to get specific details about an API. Kind of how that goes. So let's go into the first one, which is the assistant using your camera. So I can go through the code. So essentially what we have here, so the libraries that we're using OpenAI, we're using some sound libraries, speech recognition, Whisper from OpenAI, and stuff like that. So kind of getting into the code and how it's working here. So we have this method right here that kind of captures an image using OpenCV. So it's taking in the frame and, essentially, capturing an image and saving it. And this will be used to be fed into the model as an input. So here we have encoding of an image, which is required for putting into the GPT model, encoding in base 64. Here we have the assistant, which is actually taking all the inputs in and putting it into the model here. So essentially what we're doing is we're capturing the image and we're storing the image as as the captured image.jpg, and we're kind of encoding the image, and then we're setting up a client with OpenAI, and we're putting it into this response here. And we're using the GPT-4 model, and essentially the prompt for the system is you're an assistant, help the user with their question. Response should be 2 sentences max. And for the user, we're just putting the text in and the LLM input. And the LLM input is just, whatever they say to the, their mic or whatever. And the image is going to be basically just taking a screenshot, or not a screenshot in this case, an image from their camera to basically put that into the model and help them out with whatever they're doing. So we also have this part here where we're doing detect and record audio. This is very important for capturing audio, as currently the GPT-4 model cannot do that natively. But hopefully we'll get that in the next week or two, where the GPT-4o model will directly involve all modalities. Currently it's only the two, but right now that's kind of what they had in their demos and kind of demonstrating how you can do that on your own. So essentially what we have here is a threshold for when a person's speaking, and that's basically if it goes above the threshold, you want to turn the mic on and start recording what they're saying. And essentially it's doing that, it's doing all that, making sure that your thing's over the threshold, your thing is over the threshold, and you start recording, and you're basically saving it to this file called voice input. And to detect when you're starting recording, we're using this thing called SR Recognizer, which is sound recognition library. All the libraries to download are available in the GitHub, where you can see like which ones I've downloaded with pip. And then we have our main loop here, which essentially allows us to have this while loop that goes through and prompts them for their voice, and essentially asks them, takes that voice in. So we can go to the step by step. So we have LLM history, which is going to basically take all of your previous methods and messages from OpenAI, from the chatbot, and then puts it back into the model as an assistant for context, which is really important if you're doing something that requires context over a long period of time. In this loop, we have, so first we're capturing the image, we're turning on the camera, and then we're feeding that captured image into the model as we saw earlier, which we can use the frame to basically put into the model. So then we take time.sleep for 3 seconds just to make sure that it's captured and everything. We detect the audio and record the audio, and it's saved into that MP3 file or that WAV file. So then we're loading our model from Whisper. You can use the base model, or it goes up even higher based on like if you have more compute power on your computer. you can, do a lot more than just the base model, but base model will give you some latency, but it's not too bad. And you can basically feed your audio file into this model, and essentially will transcribe what the user is saying. So this part right here is basically transcribing what the user is saying using the Whisper model from OpenAI. And basically you're using the LLM input, and then you're storing it into this thing called LLM input, and that's going to be just like a text representation of what the user said out loud. And then what it's going to be doing is it's going to take that, it's going to take this method that we saw earlier, assistant, and it's going to feed that LLM input into it, feed the captured image from that, and then also feed the LLM history, as well as the OpenAI client, which you can use to generate its output. And once you get that output, also you're going to be, obviously feeding the history in, so you can, add the history, including the output of this, so you can continually have context as you go on. And then, you would print out that LLM output just to see what it looks like, but obviously not needed. And then, so then now this is the part where you want it to respond to you. So the model is going to be responding to you using OpenAI's text-to-speech model, and essentially you would just put in your text output as the input into this model, and then it would say it out loud for you. And then it would just use this play sound library from using Python to essentially play the audio that it kind of outputs. And then you can add any time.sleep there if you want like a couple seconds to reset. Yeah, so that's pretty much the code here, and I can do kind of like a live demonstration. Before that, I can just show you like the test here to see like what's going on. So essentially here, this is like a camera view of what I see. And so I have this math problem here that I'm going to be asking it to help me solve. And so that's just a test. You can use that when you download this GitHub repo to make sure your camera's working and everything like that. Also want to make sure that our audio is working. So we have this audio capture test. And what this again, what this is going to do is it's going to wait until it detects you talking, and then it's going to start recording, because you don't want like all the stuff before. That might be too complicated for the Whisper model to understand. So as soon as I stop, if you look at the bottom here, actually I should tell you guys. So if you look at the bottom here in my terminal, you can see it says start listening for audio, and then as soon as I start talking, it's gonna say start recording. Hello, testing audio, and there we go. You can also adjust your threshold here to make sure that if it's too quiet or something like that, you can adjust it based on your microphone and stuff like that. And then it saved it to this output.wave, and there we go. You can also adjust your threshold here. I'm not sure if I shared audio. Akmal or Matt, can you confirm?
Yeah, I heard you clicked play. Yeah,
okay, cool. Okay. Now I'll just go through the assistant code here, and we can get started. Hey GPT, so can you help me solve this problem? I'm having a little bit of trouble. So you can see it captured the image, stored it into this JPEG, and here's the GPT.
Sure, let's solve the equation step by step. 1. Combine like terms on the left side. 3x plus 3x minus 4 plus 6. 2. Simplify. 6 plus 2, 8x minus 4. 3. Move the 6x to the right. 2 equals 2x minus 4. 4. Add 4 to both sides. 6 equals 2x. 5. Divide by 2. X equals 3.
Okay, so I took this next step here, and does this look right to you? So it stored the image. Let's see what it looked like.
The next step shown seems incorrect. Combining like terms from the original equation, 3x minus 4 plus 3x plus 6, 8x minus 4, should give 6x plus 2, 8x minus 4, not 6x minus 4, 8x minus 4.
So I made a mistake there, and let's see if I do it correct now. Let's see if it'll correct me, or say I do it right.
Was that mistake deliberate, Ayush, or was that a real mistake?
No, it was deliberate. I just wanted to show it working here.
That's awesome.
It's to make sure. Okay, I'm kind of talking while the model's going. let me just do that again. And now I made the right step and see what it does here. Okay, so now I, made the right correction here. Does this math equation look right? So let's see what I got here. Captured image. Oh,
The image appears to be completely dark, so the math
yeah, so it
equation
didn't
is not
capture
visible.
properly. I wasn't actually.
Could you please provide another image or describe the equation?
Yeah, let me do that again. But it seems to be using the wrong camera. Um, let's see why. I think it might just be a camera issue on my end because it seems to be just be dark here. But yeah, that's just a basic demo there. I also have a video of it as well that I can show later. But let's get into the computer assistant because this is a lot more cool in my opinion. It's actually using your screen where you can screen share and then use RAG to basically take context from an outside source and then use that to help it respond to your question. So we're doing a similar thing here where we're encoding the image. With this method, we're taking, with the assistant here, what we're actually doing is we're taking a screenshot of your screen as soon as you start talking. And then essentially what it's going to do is encode that image in base64, feed that into the model here. And what the prompt here is actually, we're saying we're using, the provided prompt and the image to give an answer. If it's not in the document, do not answer, right? We want it to be contextually relevant here and not, access something from the internet or access something that's not, available to it directly within the context of the RAG. So we have, the user question. We're feeding in the user question with the LLM input, and then we're putting the context document here. Now I can show you how you can get that context document using RAG in a couple seconds here, but obviously then it returns the text, and there we go. A similar method for detecting and recording audio. You guys can check this out more in detail later. And I reduced my threshold a little bit based on my microphone. And then, yeah, and this method is where the magic happens with the RAG, right? So we have, essentially what we're doing is we're using SingleStore DB as our vector database, which is a really powerful tool because essentially all your, components with, anything that you're doing, text-based or code-based, anything like that, when you're accessing something from an external source, it's really cool and really efficient to use something like vector search, where it's finding the most similar documents based on your query. And the way that it does that, it kind of vectorizes your query and it vectorizes all the documents in the database. And then it finds like the most similar results by using something like cosine similarity or some other vector similarity search. And SingleStore DB is a really effective way of doing this. And it's one of the best ways you can do it today with this AI application. So essentially you initialize your SingleStore DB database here. You actually do this thing where you actually load in the document here. So I'm using the PyTorch documentation, which is the text file. I kind of just like downloaded their documentation and put it into a text file. So it just looks like this, just a bunch of raw data, right? Very difficult for if you feed this all into the model to do accurately. But if you're using something RAG, it's going to find the most contextually relevant responses of parts of the document and then feed that into your model. Here, what we're doing is, loading documents and then splitting it based on a chunk size of 2,000 characters. And yeah, then you would create your documents. And then you would create your embeddings, which is essentially taking all these documents and then turning them into vectors, which is really important for that vector similarity that we were talking about earlier. So we're using OpenAI embeddings, which is going to take these and turn them into like 128-dimensional vectors. We're using SingleStore DB as our vector DB here. So we're essentially creating a table with their documents, with their embeddings, and then we're just calling the table name data. And it's pretty much a similar loop here where we actually detect and record the audio. Then we feed it into the Whisper model to get the text from their voice. Then we essentially use the vector similarity from vector SingleStore to take in the LLM input and then find the most similar documents. And then now what we do with that, it's a little bit different in this part from our earlier, is we have another parameter here called context, which we kind of showed earlier, which is fed directly into the OpenAI request when you're trying to get that. And obviously we feed the history in, which is going to improve the context over time over your previous messages. And then, yeah, we've just essentially just output it as a voice. So I have this notebook here that, I was trying to work on, some training some models with PyTorch and, some basic code here. I'm going to ask, this computer assistant, if it can help me understand some aspects of the code. Before we do that, I just want to show kind of what the SingleStore portal looks like, where you can see all the vectors here. So you can see you have your you have your content, which is basically the documents, the raw data of the documents. And you have these multi-dimensional vectors, which obviously don't look like anything here, but they're these vast 128-dimensional vectors that represent the semantic meaning of the relationships between the words and allow us to like find them really quickly when we do something like a vector search. And yeah, I definitely advise trying this out. We have with SingleStore, there's a free tier where you can just use it directly and use it as much as you want. So it's really perfect for doing something like this. But yeah, let's kind of run this computer assistant here. So I'm going to be looking at this thing and I'm asking questions about it. Hey GPT, can you explain what this two tensor is kind of doing here?
The tensors in the provided context demonstrate the concatenation of multiple tensors. The torch.cat function is used to concatenate a sequence of tensors along a specified dimension, resulting in a larger tensor made by joining the input tensors.
And fed into the model.
In this case, 3 instances of the same tensor are concatenated along the second dimension, dim equals 1, creating a wider tensor.
Hey GPT, can you explain the nn.module here and explain what the ReLU is doing? So you can see it captured this with the Whisper API, and this is the output from the model, and it takes a couple seconds to like.
The nn.module in PyTorch is a base class for all neural network modules, and it's used to define models. The ReLU function, defined as nn.ReLU, applies the rectified linear unit activation function, which replaces all negative values in the input tensor with 0, effectively introducing non-linearity to the model. In the provided context, the ReLU function changes all negative values in the hidden 1 tensor to 0, while positive values remain unchanged.
Awesome. Can you explain kind of what this training loop is doing here and what the optimizer function is? So it seems like the fastest part is the Whisper model, right? It pretty quickly translates that to text. The hardest part is it putting into the model. So that took like a couple seconds there, and like the final part of
this training loop iterates over batches of data, calculates prediction errors using loss FN, and backpropagates the loss to update the model parameters.
Quick to use model.
The optimizer function, specifically torch.optim SGD in this case, adjusts the model parameters based on the computed gradients. This process is repeated to reduce the model's prediction error over time.
Awesome. So I think that's a pretty cool demonstration of that. And then obviously that this is really similar to Copilot, right? If you have something like Copilot on your VS Code, but if you're using Copilot, you can't really talk to it, right? So the whole thing with the OpenAI's demonstration that they showed a couple of days ago was, you screen share and then you just talk to it like you're doing pair programming with someone or that type of like situation. And that really allows you to do. Obviously here we had like 5 to 10 second delays, but once they fully roll out the model from GPT-4o, where it's all integrated into one, where you don't have to use Whisper separately, where it's all integrated in one, then it'll be a lot faster responses, I'm sure. But yeah, I think we can definitely get into questions now, Matt.
Awesome. I think the first question I'm gonna use my own, but lots of people are asking similarly. It's just about the timing of this, and you kind of answered this at the end, but I wonder if you could elaborate a little bit, just in terms of on stage, their version, you could interrupt it, and it was just really quick response times. Are you saying that just everything is going to get sped up when all of the features are released through GPT-4o, or what's the difference?
Yeah. So what we saw from the demonstration from OpenAI is a lot faster, obviously, because they had the model all in one, right? All the voice inputs, the voice outputs, the image inputs, the text inputs, all is one model. It's all one trained neural network. I'm pretty sure OpenAI hasn't fully released that model where we can use it yet with an API, but I'm pretty sure that's coming on the next week or two. But the only thing with this model with GPT-4o is we can see like a lot faster responses, which it was pretty fast in just response. Like you put an image and the text in, and it's giving a response within like 1 or 2 seconds. The hard part was, the most of the time was actually like, taking the response from Whisper and then putting it into the model and then putting the model back into the text to speech. But hopefully with their model that they released in a couple of weeks, it will be all integrated into one where it's going to be a lot faster.
Awesome. Akmal, I know you've been very active on the Q&A. Anything that you already answered or anything that stands out that you want to start with first?
Yeah, I think Robert asked the question. He's saying, could you say a little bit about your camera setup, Ayush?
Oh, yeah.
How are you
Yeah,
using one camera for Zoom and one for Omni?
Yeah, I was using my phone as like a external camera and then kind of just like, showing the screen. Obviously it went black because I think it was confusing my computer camera with my phone camera there. But yeah, it's definitely, you can set it up however you want. You can, if you're using this as the repo, you can use your computer camera or you can use your phone camera, whatever works best.
Okay. There was another question here from Seth asking about the vectors, I think, that you used. And I apologize, I was paying attention to the questions. I was listening to what you were saying, but not looking at the screen. So he was asking that if I just quote him, says, the vectors in SingleStore had some random characters and not numbers. I don't understand why that would be the case. And I think that's the internal representation, isn't it, that you were showing? There we go. Yes. So that's JSON array pack. So what SingleStore does, it's an internal representation that it uses, and you basically use array pack and unpack in order to get back something meaningful, human readable. But that's essentially what we're looking at there is something that we don't understand, but the database certainly does, and it will store that and keep that for us. By the way, the new vector type can actually show it as just text. It will not be this representation. So that's one of the cool features of the new vector data type that we have.
Awesome. And I can go over one question. So it says, can we interact with real-time videos parallel using GPT-4o? So currently you can't have video inputs into the model, but hopefully that's something that introduced with the fully rolled out GPT-4o model. As you can see, what I was doing here was I was just completely inputting like an image, and as soon as they started talking, as soon as we detected their voice, and they stopped talking, we kind of just took a screenshot of their, if we're using the OpenCV for their camera, or we're just taking a screenshot of their screen, depending if they're using a computer assistant or just a normal assistant.
And Ayush, all of these features should be available within days, right? I mean, they're talking about, they said within weeks it's going to be rolling out to users,
Yeah.
but that's the timeline that we're talking about, right? To be able to do send video instead of capture still images and all that.
Mhm.
Okay.
Yeah, definitely. I'm not really sure 100% the timeline on it. They said a couple weeks or so, and it should be, so I'm not really sure their timeline, but just whatever that looks like, it should be cool when it comes out, whatever. Yeah.
Awesome.
A couple of questions there relating to will it be available on Azure? I think Seth has actually posted a link there as well. And obviously Microsoft has a relationship with OpenAI, and I'm sure that the latest version will be available for their customers in due course. Not something we probably can answer unless you just find something on the webpage there, just as you did.
Mm-hmm. Yeah.
Yeah, there we go.
Okay. Mm-hmm.
Akmal,
yeah,
I see one that's interesting here, and there's been a couple questions about it, so I'll try to summarize them into one. How does the vector database come into play here? And one of the questions is like, can it reduce the large context that you need to provide to ChatGPT? Or other people have just asked, like, generally, how is the vector database involved when you're building an application, I guess, with LLMs?
Yeah, great question. So think of it as this long-term memory, okay? And it's gonna, you do that process that Ayush is showing right there, okay? So those kind of funny characters there, that's the internal representation of the vectors stored in a database. So you've gone through the time, effort, money, whatever it is, the resources to generate those If you only need them on the fly temporarily, obviously there's no point in keeping them. But the thing is that if you're looking longer term, there may be some critical data that you're dealing with, and representing that in a vector way, as well as storing the original data, perhaps, okay, maybe not. It depends on your needs. Then a database management system is ideal, simply because it offers all of these capabilities in terms of multi-user access, consistency, isolation, durability. Short of an asteroid hitting the Earth and killing us all, I mean, there's multiple data centers around the world, right? So if things go down in one region, say North America, Asia Pacific is still running, Europe is still running, and these global, cloud providers, Microsoft, AWS, Google Cloud, they have the capability that if you've replicated and have this capability of your data existing in multiple regions, that gives you confidence that your data is still there. You can still run your systems. And so think of this as really long-term memory, that the ability to remember things and then be able to use them again and again in the future. And that's really where a database comes into its own. That's my take.
Awesome. Ayush, do you see any questions that stand out to you? I know we probably have more than we can answer in 3 minutes, so maybe one or two more before we wrap up and do the raffle winner.
Yeah, let me just scroll through these right now. Someone asked, I missed, how did you share your screen with GPT? So I can just show that really quickly. It was just using this API called Pi Auto GUI, and essentially what you can do is you can just, it's literally like one line of code. You can just take a screenshot as soon as the user starts talking, or when they stop talking. You can take two screenshots. Maybe what you can do is you can do one right before they start talking or right after, and then feed those both into the model if anything has changed. But yeah, that's just all that's happening, and you just encode that in base 64 and then feed that directly as a part of the prompt from the user. Let's see. Someone asked, how often do you hit token limits, or what's your invoice for tokens to OpenAI look like? So I don't hit token limits that often, but I wasn't using this too often, so I don't really know. But I think definitely the pricing has definitely gone down. Obviously, like it's 50% cheaper with this new GPT-4o model, so that's really great. So the per token cost is 50% cheaper than GPT-4 Turbo, which is the predecessor model. So it'll be really great for scaling your applications and stuff like that. But yeah, I'm not really sure the exact price, but it's definitely on the OpenAI's website. You can check out.
Awesome. I think in the last minute now we should probably wrap up and do the raffle winner. There's been a couple questions about the upcoming webinars. I just reposted those links into the public chat, so feel free to register for any of those or all of them if you like. There's also been lots of questions about, will we get this recording? Will we get this GitHub link? Yes, everyone is going to get an email with this video recording to watch on YouTube and Ayush's GitHub as well, so you can try it out yourself. So let's get to the winner of today's raffle. It goes to Muhammad Khalid, Payments Engineering Manager at Scotiabank in Ontario, Canada. Congrats, Muhammad. Thank you for joining. If that's not you, don't give up. We're going to give out one more prize, either the AirPods or the Ray-Bans, the smart Ray-Bans, by the end of the day to someone who has tried out Ayush's demo. So keep an eye out on your email for that. Click, try it out, and we're going to give out one more winner today. Thanks, Ayush, for an awesome presentation and demo as usual. We really value your time. You've always got great stuff. Thank you, Akmal, as well, for awesome support during the Q&A. And thank you to our audience for joining us. Have a great rest of your day, everyone.